Again, everybody, we're on to 3.4. Let me bring it up. We go. So we've done a lot. Quick recap: 3.1, the derivative rules for polynomials and for e to the x. 3.2 was a big one, the product rule and the quotient rule. And 3.3, we saw all of the derivatives for the 6 trig functions. And we recognize that, every time we learn new rules, we can always fold them into the previous rules. So they can all play within and, just kind of within and between each other. 3.4, the chain rule. Let's get to it. What's this all about? Kind of a different feel to this rule. The chain rule, and we'll see where that name comes from, sounds kind of scary. The chain rule is finding the derivative of a composite function, something like f of g of x. And it turns out that, composite functions, these are really, really typical, and we haven't done any derivatives of them yet, but when we think about functions, composite functions are really, really common. Maybe we haven't even really thought of these things as being composite, but we see a few examples there. Y equals the quantity x cubed plus 1 to the 10th is a composite, right? F of g, like the g of x would be the x cubed plus 1. The f of x would be then raising it to the 10th. Okay, or how about the next one? F of x equals the cosine of x to the 4th plus x squared plus 2. Or even something like y equals e to the 5x is a composite function. Okay, so we'll look at all of these derivatives and more as we go through this section. Let me tell you the rule. Here it is. Without any delay, the chain rule says if you're looking to take the derivative of f of g of x, it's equal to f prime of g of x times g prime of x. So a couple of things to notice. Notice there are, 2 pieces to it, and you multiply them. So we call it the chain rule because this would be like the first link in the chain and the second link in the chain. The first link in the chain, you take the derivative of what we're going to call the outside function. So the outside, if you will, you're going to hear me referring to the outside function and the inside function a lot. The outside is, of course, the f. So we take f prime. Notice that we don't change the g at this point. It's just going to get copied over. Once we're done with that, we multiply. Now we take the derivative of the g, and it's like that second link in the chain. Let's see this with our first example up there, just kind of make sense of it. Chain rule, it's nice to have the rule written out and refer to it, but chain rule, you really got to learn through example, just the way that it plays out. So, okay, so if we take, say, y equals x to the 3rd plus 1 to the 10th, what are we working with here? What's the f and what's the g? So I mentioned earlier, so the g, it's almost easier to identify the inside function. The g is literally inside these parentheses. It's the x to the 3rd plus 1. The f is telling us, okay, now raise that to the 10th power. Okay. So think of the 10th power as the outside function. So what does the rule tell us to do? It says take the derivative of what's on the outside. So, well, okay, the derivative of the 10th power, no problem. We know the power rule. The derivative of the 10th power would mean this 10 goes down to the front, and then it drops to a 9th power. Okay, so kind of like this. Let me just write just this much so far. We bring that 10 down to the front. We've got this set of parentheses, and then that is going to drop by 1 to make it a 9th power. Now, why do I leave what's inside here blank for the moment, just so we can focus on the derivative of that 10th power for now. Also, okay, now what goes inside here? Notice that it just says g of x. The original g of x is just going to get copied. We don't touch that at this point. So we're simply just going to copy over the x cubed plus 1. Okay, so there's the first link in the chain. Then we're going to multiply. And next comes the second link in the chain. Okay, here is where we focus on the x cubed plus 1. Now we take the derivative of that. And of course, it's 3x squared. So that's going to go on the end. So there you have it. The derivative of the 10th power with the what's inside the parentheses just copied. Multiply, then go to the derivative of what's inside the parentheses, and you have it. Of course, we can, excuse me, we can clean that up pretty well. Maybe we move that 3x squared, multiply it with the 10 here, giving us 30x squared times the quantity x cubed plus 1 to the 9th. Okay, very cool. Let's see that for some more examples. We've got a few here. I'm going to go to my paper here in just a moment. But you know, we really get a good variety. So we've got some trig. We've got another little trig piece down here with a tangent. We've got a quotient that's being raised to a power, right? E, we got a couple examples with E. Turns out E can give people some trouble with the chain rule. So we'll look at a couple of those. And then finally, we've got a square root. And notice there's even a product here, 7x to the 4th times the square root. So this will use a product rule as well. Okay, cool. Let's jump over, handle these one at a time. Find the derivative. Again, if this was on a quiz or a test, and all I said was find the derivative, then there'd be no need to simplify. We will practice simplifying because that's a good idea, you know, for lecture purposes for sure. Okay, we'll start with f of x equals cosine of x to the 4th plus x squared plus 2. What I like to do is label, like even with arrows, what's the inside and what's the outside. So here, there's my inside function, the x to the 4th plus x squared plus 2. It's literally inside parentheses. Most of the time, your inside is literally going to be inside parentheses. And then we've got our cosine, and that's our outside function. Okay, so when we find f prime of x, we start with the outside, of course, and work our way in. So what's the derivative of cosine? And if you remember from the trig derivatives, derivative cosine, it's a co, so that means it's negative, and its friend is sine, so it's negative sine. Now, negative sine of what? We're just going to copy this part for now. That does not change. We just take the derivative of the cosine, copy the rest. Then we multiply. Now we can take the derivative of what's inside. And because there's more than one term, we're going to need parentheses. 4x cubed plus 2x is that derivative. And there you go. This is the derivative of the outside times the derivative d inside, if you were kind of tracking, and those are the two links in the chain. Not much simplifying to do here, even if we wanted to. You know, maybe it's probably more typical to write this out in front. So maybe negative 4x cubed plus 2x sine x to the 4th plus x squared plus 2. You know, so there's your unsimplified version, and there's your simplified, I guess, you know, it's parentheses. Okay. There you are. Next was k of x, e to the x over x squared plus 1 to the third. Okay, a couple things about this one. What's inside, what's outside? Well, all of this here is on the inside. The outside is just that third power. So to find k prime of x, we'll start with the third power. That means the 3 comes down in front, then it drops to a square. What goes in the parentheses? Well, we're just going to copy at this point, e to the x over x squared plus 1. There's the derivative of our outside, our third power. We're going to multiply. Okay, let's look at this. The derivative of the inside, notice it's a quotient. So to take this derivative, of course, we need quotient rule. And now all these rules are starting to play with one another. We've got a quotient rule happening within a chain rule. Okay, let's check it out. Quotient rule says low d high minus high d low all over low squared, and away we go. Okay, so we got the low is x squared plus 1 times the derivative of the high. Derivative high, e to the x, well, that derivative is e to the x. Minus the high, just copying it, times the derivative of the low. Derivative of x squared plus 1 is 2x. And that's all over our x squared plus 1 squared. Okay, this is a great example of the joys of not having to simplify. If all we were asking for is the derivative, you can just stop right there. Wow, wouldn't that be nice? But for the practice here in our lecture, let's go a little further. Let's see what we can do with this piece. So how about we square top and bottom, and I'll multiply the 3 to the numerator. So the 3 could go up. If I square e to the x, I multiply the exponents, it's e to the 2x. And I'm going to put it over x squared plus 1 quantity squared. And we notice that's the same denominator as here. Now we're multiplying, so we don't need a common denominator or anything, but we'll be able to multiply denominators here in a second. Okay, and with this, you know what? I think I'm just going to factor out the e to the x. So let's make it x squared minus 2x plus 1 e to the x. That looks nice. And if I keep going, now we can multiply numerator times numerator. That would give us 3x squared minus 2x plus 1. When we multiply these, now we're adding exponents, e to the 3x. And we'll multiply denominators, so that's x squared plus 1 to the 4th. Okay, and I think that's as far as we can go. X squared minus 2x plus 1, that would factor, right? But I don't think it would cancel anything, so I'm kind of leaning towards not doing that. Would that? No, we got the 1 here. Wait, minus 1, that'd be x minus 1 squared, wouldn't it? But nothing cancels. That does look just a tiny bit nicer. I kind of, maybe I will go with it. A little bit more compact, we say. X minus 1 squared e to the 3x over x squared plus 1 to the 4th. Again, nothing cancels, but I'd be happy with either of these answers, honestly. For a simplifying, depends on what you would need to do next. Okay, looks great. Looks great. You know what? Let's stop here. We've done some good examples. We'll pick it up with part C in the next one. I'll see you guys there.